This is going to hopefully help you with Chemistry 1 Worksheet 1. And what I have showing you right now is what is at the very bottom of your page, which is these triangles here. And what they mean is what's going to be at the top of this page right up here. So you have moles are equal to grams over the molar mass, which is what you find from the periodic table. You also have moles that are equal to the number of atoms or the number of molecules or the number of particles. And that is divided by Avogadro's number, which is 6.022 times 10 to the 23rd. And then you also have moles that are equal to liters over a molar volume constant, which is 22.4 liters, and that's what they usually use. The one thing I have not given you, but I will post on Google Classroom, is this mole roadmap, which I'm going to show you how to use with your chemistry worksheet. So what happens, the way that you're going to read this is that if you want to go from moles to mass in grams, you will use this arrow right here, which is molar mass over moles. If you want to go from mass in grams to moles, you will use this formula, which is 1 mole is over your molar mass, which you get from the periodic table. The other one that you'll be using on this worksheet will be going from moles to number of particles, and you will be using this 6.022 times 10 to the 23rd, which is your Avogadro's number. Or if you go backwards from number of particles to moles, you'll be using 1 over Avogadro's number. So let me show you how to do one of each of these, and then we're going to go over how to do numbers 11 through 15 also, because those are a little bit different. So to start out with, number 1 on your worksheet, it says to determine the number of grams and 0.35 moles of iron hydroxide. So with that being said, you are looking for the number of grams. They are giving you moles. So what you're going to look at on your sheet is we are going from moles to grams. So moles to grams. So we'll be using this molar mass over 1 mole. So we're going to set it up in the train tracks. And those train tracks that we usually use will be starting with what you have, which it says over here is 0.35 moles. So we have 0.35 moles, and that is of iron 2 hydroxide. And then we're going to set our train tracks up to where when we go from moles to grams, it's said to do the molar mass, which you will have to look on your periodic table, and you have 2 hydrogens and you have 2 oxygens and you have 1 of iron. So what you're going to do is take all of those masses and add them up, which is what you have been doing on the recent worksheets, and what you will come up with is 89.86 grams over 1 mole. So remember, when you are going from moles to grams, you're going to use this one right here. So moles to grams, you will do molar mass over 1 mole, which is what I have right here, the molar mass over the 1 mole. So what you're going to do is this mole and this mole right here cancels out, and it leaves you with grams. So those grams, once you multiply 0.35 times 89.86, should come out to 31.45 grams. And that is how you would do a problem when you go from moles to grams. So number 2, the way that you're going to do that one is you are going to look at it, and it says to determine the number of moles present in 43.8 grams. So you're going backwards on this one. And when we look, we see on your train tracks that you are going from grams to moles. So you will use this formula right here, which is 1 mole over the molar mass. So on number 2, you're given, and you always write your given first, is 43.8 grams of FePO4. And then you're going to do your train tracks, and you're going to use that formula that I just showed you on your road map. And for that one, it was 1 mole over grams. And once you put in 1 iron, 1 phosphorus, and multiply 4 times your mass number of oxygen, and you add all those up, you will come up with 150.82 grams. And that will cancel out here. And once you do that, you will have 43.8 divided by 150.82, which then will give you 0.029 moles. And I forgot to write the other one, but you have to write your formula of the compound afterwards. So that one, and then there's. Okay, so your next one, number 3, is going to be your determining, I can't say that, the number of molecules present in 2.75 moles of MgO. So when you do that, you are going to be going from what you have present first, which is moles, to the number of molecules. So we come over and we're going to start with what you have present first, which is 2.75 moles of magnesium oxide. And we're going to do our little train tracks. And we are going to be going from moles to molecules. So you come to the sheet right here, and you see when you go from moles to, there's the molecule right there, you're going to be using Avogadro's number over 1. So I'm going to put Avogadro's number on top. And then that would be over 1. So this is molecules. The moles will cancel out. Then you will multiply 2.75 times 6.022 times 10 to the 23rd. And you're going to have a scientific calculator for that. And that should come out to be 1.66 times 10 to the 24 molecules of magnesium oxide. Okay, so that should help you with the rest of those. Since I did 3 of those, then you can do the rest of them. Number 11 is a little bit different. So what's going on there is, let me turn the page over to number 11. So number 11, it says find the simplest formula of a compound found to contain 52.2% carbon, 13% hydrogen, and 34.8 oxygen. So what you're wanting to know is how many of each one of those, what's the ratio of each one of those. So in order to figure that one out, we're going to write those up here. So we have 52.2 of, and we're going to put those in grams of carbon. You have 13.0 grams of hydrogen, and you have 34.80 grams of oxygen. So when we're figuring those out, you are going to go to where we have to match these up. So we have 52.2 of, and it's grams of carbon. And we are going to multiply that one times 1 mole of carbon, which if you look on the periodic table, you will see that 1 mole of carbon has 12 grams in it, and that will give you 4.346. So we're going to do each one of those the same way and how much we have in those. So we have 13 grams of hydrogen, and this is just like doing the train tracks if you want to do it like that, or you can multiply it like I'm doing, which is 1 mole of hydrogen gives you, and this is the decimal form, or you can just use 1. And once you take 13 and divide it by 1.0079, then you should get 12.898. And your last one is 34.80 grams of oxygen. And we're going to multiply that times 1 mole of oxygen over 15.9994 grams. And notice when I'm doing this, and I didn't put them each on there, but your grams are canceling out, and then you're left with your number of moles. So that is going to be 34.8. We're going to divide it by the 15.9994, and that gives you 2.175. All right, so what you're going to do is you are going to look at the one that you have the least amount of. And the least amount that we have is this one right here, which is your oxygen. So that is going to be our number that we're going to use for our ratio. So we're going to take each one of these numbers, so 4.346, and we're going to divide it by 2.175, and that comes out to 2. Then we're going to do 12.898, divide it by 2.175. That one comes out to 6. And then we're going to do the last one, 2.175, divide it by itself, which will come out to 1. So that would be 2 carbons. That would be 6 hydrogens, and that would be 1 oxygen. If you have any problems, let me know, and I can do a Google Meet with you all on how to do this. But I plan on doing something for your worksheet too. Just remember to use your roadmap here in order to get the problems that you need, and make sure that you are doing opposite each other so that they will cancel out.